The flight sent back something that no one expected, something so utterly bizarre, so deeply confounding, that it has forced scientists across the globe to reconsider everything they thought they knew. A discovery so strange, so impossible, it's compelled a rewriting of established models about the boundary between our world and the vast galaxy beyond. What exactly did Voyager 1 encounter at the edge of the solar system? Why are some researchers comparing this mysterious revelation to finding a ghost in the machine? When Voyager 1 launched from Cape Canaveral in 1977, its mission was not meant to be eternal. It was never originally designed to travel beyond the orbits of Saturn. It was built for a 5-year mission, a relatively short endeavor intended to study the outer planets, specifically Jupiter and Saturn, and, if possible, to examine some of their intriguing moons. However, even in its earliest planetary encounters, Voyager was doing more than expected. It was rewriting the textbooks. The probe revealed Io's volcanic fury, exposing dynamic and continuous eruptions. It unveiled Europa's icy shell, hinting at subsurface oceans that might harbor life, and even exposed Jupiter's hidden ring system, an astonishing surprise that demonstrated just how much humanity had yet to learn about the solar system's outer realms. What began as a brief mission lasting mere months transformed into a multi-decade odyssey. Voyager 1 used a technique known as gravity assist, or planetary slingshots, to gain speed as it passed planets, allowing it to break free from the sun's gravitational grip. This ingenious maneuvering allowed the spacecraft to sail past Saturn's mysterious moon Titan, one of the most enigmatic objects in the solar system. From there, it turned northward, leaving the ecliptic plane, the flat disk where most of the solar system's planets orbit, and began heading into the unexplored frontier of deep space. By 2012, Voyager 1 had become the first human-made object to enter interstellar space, crossing a boundary known as the heliopause. This is the region where the solar wind, a constant stream of charged particles from the sun, finally loses its influence, giving way to the interstellar medium, the galactic environment that exists beyond our solar system. But the further Voyager traveled, the stranger the conditions became. Scientists had long expected that upon crossing the heliopause, there would be a sudden and definitive shift in the magnetic field surrounding the spacecraft. After all, it was leaving the sun's domain and entering the influence of the broader galaxy. But that shift never came. Instead, the magnetic field stayed nearly identical. At the same time, plasma density increased dramatically, confirming that Voyager had indeed crossed into interstellar space. Still, the direction of the magnetic field remained unchanged, defying decades of theoretical predictions. This was the first major clue that the heliopause isn't a clean, impermeable wall. It's a veil. Instead of being a sharp boundary, it's a turbulent transition zone filled with unexpected behaviors and interactions. Voyager 2, which crossed into interstellar space in 2018, confirmed this mystery when it experienced the exact same phenomenon. What had long been assumed to be a defining boundary turned out to be more like a fluctuating, breathing membrane, shaped by invisible forces that science still doesn't fully comprehend. Some scientists now speculate that our solar system is currently moving through a patch of the galaxy shaped by ancient supernova explosions, regions where matter has been ionized, rearranged, and frozen in ripple-like structures over cosmic timescales. Voyager, then, is our first probe to physically interact with and feel those ancient galactic ripples firsthand. And here's where the mystery deepens. Voyager 1, now drifting more than 14 billion miles from Earth, began sending back anomalous signals. These were data transmissions that didn't align with any previous patterns. At first, engineers believed these irregularities were due to an instrument failure, perhaps a glitch in the aging memory banks of a spacecraft more than 4 decades old. But as they examined the timing of the signals, the patterns in the data, and the broader context of these events, the situation became far more bizarre. Voyager's instruments were detecting subtle rhythmic oscillations, almost like a heartbeat. These pulses weren't coming from the spacecraft itself. They were coming from the space surrounding it. Voyager had entered a region where plasma waves echoed in structured, repeated bursts. These weren't random disturbances or background noise. They had rhythm. They had consistency. And possibly, though no one dares say it definitively, they had intelligence. Of course, no one is jumping to the conclusion that these signals represent alien contact. But the question remains, what kind of natural process could generate such precise, repeated energy pulses in interstellar space? It doesn't match any known phenomena observed from stars, pulsars, or galactic currents. Voyager may have stumbled upon a cosmic structure, an energetic corridor, or an unknown boundary in the galactic medium that behaves in ways our current physics cannot explain. What makes this moment even more powerful is the nature of the probe itself. Voyager 1 was built with far less computing power than the simplest modern digital watch. Its memory is recorded on 8-track tapes, the same kind used in 1970s car stereos. It runs on nuclear decay, not solar panels, and yet it has withstood the cosmic radiation, the cold, and the darkness of space. And it's still sending signals. On board is the iconic Golden Record, a time capsule filled with sounds and images from Earth. It was designed by Carl Sagan and others as a message to whoever, or whatever, might one day find it. A bird's song. A mother's kiss. Beethoven. Greetings in 55 languages. A map to our planet. That tiny golden disk is now the furthest human artifact from Earth, still drifting, still waiting. Voyager 1 is more than a machine. It's a mirror. And as it now sails through a region of space where the laws of physics blur and logic strains, it may also be sending us a message, not only about the cosmos but about ourselves. As Voyager 1 continues to drift deeper into interstellar space, scientists are beginning to notice that the disturbances it records are not just chaotic static. They form patterns, structures. Plasma waves rise and fall with a symmetry that seems impossible. Magnetic field changes occur in rhythm. Radiation spikes echo over intervals that seem too precise to be coincidental. What does this all mean? It means that Voyager may have entered a region of space that isn't as empty as we believed, but rather one that is organized, structured, not random, not uniform, shaped. Researchers are now entertaining the possibility of what they call a plasma lattice, a kind of unseen cosmic scaffolding. This may hold vital clues to how the galaxy distributes energy, gravity, or even information. This idea isn't new. For decades, cosmologists have speculated that the universe might be threaded with invisible networks of energy. But Voyager may now be the first probe to fly through one, and actually feel its presence. So the question becomes, what created this structure? Is it a remnant of a stellar event long past, perhaps the ghost of a supernova? Or is it part of a persistent galactic mechanism that we've never before had the ability to measure or perceive? If this theory is confirmed, Voyager 1 will have provided the first direct evidence that space itself may be built upon a hidden architecture, one we're only now beginning to sense. Voyager 1, with no propulsion and no course corrections, now glides under the inertia it carried from 1977. And yet, it has passed through so many unique and improbable cosmic phenomena that theorists have begun to ask a troubling question. What are the odds? Out of all the directions it could have gone, why did it end up here? Why now? Some speculate that Voyager may have unknowingly flown through the most information-rich corridor possible, a path carved by the solar system's motion through the galaxy, like a current in space-time. Perhaps it was pure coincidence. But the alignment of discoveries, from the heliopause enigma to the plasma anomalies and now to these coherent energy signals, makes the journey feel almost guided. This has led a few bold researchers to consider a radical idea. Could there be informational flow in space? Could gravity, plasma, and magnetism not only shape matter, but shape pathways? Could Voyager 1 have become part of a galactic feedback loop, where a system observes itself through our machine? There's something surreal about Voyager 1's continued success. The older it gets, the more powerful its discoveries seem to become. Its instruments outdated. Its power supply is fading. And yet, it is revealing truths that modern telescopes have not even come close to. That, in itself, is forcing scientists to reevaluate not just the cosmos but how we approach it. We often view the universe as something to conquer, something to map, measure, categorize, and control. But Voyager reminds us of something older, something deeper, the value of observation without interference. Of listening rather than measuring. Of drifting rather than steering. In its silence, Voyager teaches humility. In its endurance, it teaches patience. And in its impossible discoveries, it teaches wonder. It's no longer just a probe. It's a symbol of cosmic awareness, an idea that perhaps humanity was not just made to look at stars, but to learn from them. Even when the lessons come in frequencies we barely understand. Voyager 1's tiny plutonium power source is fading. Within the next few years, its instruments will fall silent, one by one. Eventually, it will become a dark, drifting object, invisible and unreachable from Earth forever. But before that day comes, it continues to send back data. And what it's sending now may be the last great discovery of its mission. It is detecting energy and motion in regions where there should be stillness. It is receiving structured patterns in places where randomness should reign. It's behaving not like a lost relic, but like a final witness, recording the breath of a universe that is only now beginning to reveal its true face. When Voyager finally goes silent, it won't just leave behind a scientific legacy. It will leave behind a philosophical one. The memory of a tiny machine that crossed the boundary between what we know and what we don't, and for one brief moment, listened. Voyager once set out as a machine. It became something more. It became a question carved in metal, floating in silence, asking the universe if anyone was listening. For 45 years, it has drifted, beyond planets, beyond the sun's reach, into places no human eye has seen. And now, in the twilight of its mission, it has touched something impossible. Not a wall. Not a signal. A mystery so profound, it defies language. It didn't find aliens. It didn't find God. But it may have found the breath of the cosmos, a pulse, a rhythm, a whisper from the very edge of what we call reality. And as its signal fades, as its systems shut down, as it passes into legend, one truth remains: Voyager is no longer merely exploring space. It has become part of space. And that is what makes this discovery so haunting. Not that the universe is stranger than we imagined, but that it waited this long to begin speaking back. What do you believe Voyager 1 truly found out there? A natural force? A hidden law? Or the beginning of something far greater? Leave your thoughts in the comments. Share this story if you believe in the journey of a little probe built by human hands. And as its signal fades, as its systems shut down, as it passes into legend, one truth remains: Voyager 1 has not only expanded the frontiers of science, it has touched something deeply human, our thirst for meaning. For all its wires, transistors, and radioactive fuel, what Voyager truly carried was a question. What lies beyond? Not just beyond our planets, not just beyond the sun's grasp, but beyond understanding itself. It is not merely data the spacecraft has transmitted. It is ore, transmitted in ones and zeros, etched across decades, through the cold and the dark, across a distance so vast it boggles the mind. And yet, there it is, still sending. And with each signal, scientists gather in rooms lit by soft blue screens, scanning charts and spectrographs, reading the silent pulses like tea leaves cast across the canvas of space. Some of those signals look like interference. Others repeat with mathematical precision. There are data strings that resemble prime sequences, bursts of plasma energy that correspond to geometrically patterned waves, patterns that mirror some of our own earthly phenomena, yet are out of place and time. Many try to rationalize these anomalies as natural occurrences: turbulence in the interstellar medium, statistical noise, radiation belts. But even in those rationalizations, there's hesitation, because they've never quite seen anything like this before. What makes these patterns so compelling is that they do not appear random, and yet they defy categorization. They are not the signatures of stars.